Hey everyone, this is Mrs. Gifford, and today we are going to talk about a new form of writing equations called point-slope form. So after this lesson, you will be able to, again, write equations in point-slope form. So let's do a quick review here before we go on and talk about point-slope form. The two forms of equations we've talked about so far are slope-intercept form and standard. Just a real quick review. In slope-intercept form, the y and the x are both variables. M, we know, is the slope. Again, that tells us the steepness of a graph. And b is the y-intercept. And that tells us where the coordinate graph obviously crosses that y-axis, and it has that coordinate pair of 0, comma, whatever b is. Standard form is similar. Just like in slope-intercept form, the x and the y that we see are variables. And then the a, b, and c in this case are all numbers. So let's look at this new form of equations we have called point-slope form. And let's talk about the parts of it and then again when we would use it. So just like the previous two examples, when we see the plane y and the plane x, these two are variables, so there's some consistency there. And then the m, what do you think the m is? If you're thinking slope, you are 100% correct. So again, the m is consistent between this one and slope-intercept form. And if you also think back to the formula that we used for finding slope, to find that rise over run, we would use coordinate pairs. Well, in point-slope form, the x and the y come from a point or a coordinate pair. So again, going back to why would we ever want to use this equation versus slope-intercept form, it has solely to do with the fact that if we are given slope, like we talked about up here, if we're given slope with the m, and if we're given a coordinate pair, that's when we would use point-slope form, which is different than slope-intercept form. Slope-intercept form, again, we would use that one if we have slope and we knew the y-intercept. Okay, so that's the difference between why we would use those two equations. So let's take a look at our first example here, and it talks about in this equation let me put a screen up here real quick. We're going to write equation in point-slope form through this given point and slope, and then we're going to graph it. So we have this example where we know that the slope is -2 and crosses through -4, 7. So the first thing that I'm going to do is write down that general form of point-slope form. Y minus y1 equals m times the quantity of x minus x1. And then I'm going to plug in what I know. Again, here is our slope, this -2, -2, -2, that goes in for the slope. And then we're going to take the coordinates, oh, I have a typo here. We're going to take the coordinates from our coordinate pair, from here, and substitute them into the equation. So this is y minus 7. Here's our 7. And this actually should say x minus -4, not -7. Sorry about that. Okay, so we put the coordinates for the x and the y in for the formula, in the x and the y up here. Put our slope in, and then the other thing that you might recognize is this is x minus -4. So you might want to consider changing that to be x plus 4, because we talked earlier and you learned last year that subtracting a negative is the same as adding a positive. So this is all you have to do if you know the slope and the coordinate pairs. Then the next thing the directions want us to do is to graph this equation. So I'm going to simply do it right from what I have given. In the last chapter, we worked on graphing from the intercept and then using the slope to find points. But what we're going to do now is go to the coordinate pair -4, 7. -4, 7. There's my coordinate pair. And then I'm going to use my slope of -2. Well, if my slope is -2, what am I going to do from that coordinate pair to find another one? Right, if you're thinking down 2 and right 1, you are absolutely correct. So from that pair, I'm going to go down 2, right 1. There's my point. I like to put 3 just to help make it consistent. And there's that line that I graph. So again, plug the numbers into the equation, simplify it as best that you can, and boom, you're done. So let's take a look at this second equation. Now we're going to go reverse. We have a graph, and we're going to write this equation in point-slope form. So the first thing that you want to do is remember, again, the x and the y in the equation are plane variables. The m represents slope, and the x1, y1 come from a coordinate pair. Well, we could use any of the coordinate pairs that are on my graph. I'm just going to use this one up here at the very top. So the first thing that I want to do is decide what, or figure out what that coordinate pair is. So looking at where it crosses the x-axis, this coordinate pair is 2 and 7. So I'm going to use that in my equation, and I know that the y is the 7. So I'm going to start my equation with y minus 7 equals, I don't know my slope yet, and then I'm going to do x minus 2. Okay, so then the next thing now that I have to do is find my slope, and we talked about doing that also. If I think from this y-intercept to this point right here, I ask myself, what's my rise? I'm going up 2, so that means a positive 2, and I'm going to the right 1, which means a positive 1. So if I think of my slope, my rise over run simplifies to 2. So I'm going to take that number, that 2, and I'm going to put it into my equation for where the m is. Again, m is slope, x1, y1 are the coordinate pairs. So the last example I have for you today, we are going to take a look at this equation. This equation is already in point-slope form, and now we are going to put it into slope-intercept form. So immediately when you hear putting it in slope-intercept form, I'm hoping in your head you're thinking, oh yeah, that means I need to put it in y equals mx plus b form, which means I need to isolate the y variable. So we're going to use what we learned earlier this year about solving equations just to get that y to be alone or isolated on that left side. So again, we already know this is in point-slope form. So the first thing we need to do is get rid of that 7 outside parentheses. And so what do we call that when we do this arrow thing? Right, that's the distributive property. So I'm going to bring my y minus 4 down. And then I'm going to distribute that 7 through. So 7 times x is 7x. And 7 times negative 2 is negative 14. So far I've gotten rid of the parentheses by distributing, and now again I need to isolate y, which means get it by itself. And so now I need to think of, well, what undoes, or what's the inverse of subtracting 4? Right, so I'm going to add 4. And as we know, rules of equations say whatever we do to the left, we have to do to the right. So I'm going to add 4 underneath that minus 14 or negative 14. The 4's cancel, and it leaves us with y equals. I don't have anything else to do with that x, so I'm going to bring 7x down. And then from here, we have negative 14 plus 4, which is negative 10. All we did was distribute and then get rid of, or use the inverse operation to get that y all by itself. So there you have it, folks. Today's lesson is all about working with point-slope form. Have a good one.